Okay. So again, we can have transformations of natural logs just like we had them with the other logs. What does it generally do when we subtract 2 inside of a function? Right? That should have been a right 2. Now, the next one, you probably need some help looking at that one. But understand that the you have a homework problem which is almost the same thing. I think it's 1 minus x. So notice how I do this one and then try to base what you're doing on this pattern here. Remember that, let's say that I have a function, f of x. What does it do to the function if I put a minus in front? It's, that's a flip across the x-axis, right? Or the way the book says it, a reflection in the x-axis. Okay, if you do f of negative x, meaning you put the minus inside the function, that was the reflection in the y-axis, right? Flip across the y-axis. Now, if I rewrite this one like this, this is ln of negative x minus 2. Right? Negative x minus 2 is the same thing as 2 minus x. Now, what are the transformations? The minus 2 still means
over the x, the y-axis, and then a
right 2. Right? The minus 2 means right 2.
Flip over the y.
Right? And then reflection in the y-axis.
Wait, so you can just...
And generally, you can do the one inside first, and then you do the one on the outside.
So you don't just make it negative x plus 2.
No. Okay, so there's our 2. If we look at the next slide, these are the graphs of those 2. So the first one, ln of x minus 2, we shifted our graph 2 to the right. What did that do to the domain? Remember, that moved the asymptote there. No? It's greater than 2. It's not or equal to. Remember, it's an asymptote at 2. Okay? Now, notice what this one did. It shifted 2 to the right, and then now it's pointing the opposite direction. That's because of the minus in front, right, inside the function. So we would have expected that it goes like that. Now it's going like that. So now, the asymptote is still at 2, and x is less than 2. That's it.